Okay, so that actually, well, it doesn't wrap it up. We actually have one last special guest here. You guys all heard of this project. It's called DFINITY. We have Dominic Williams, who is the chief scientist there. I think it's his first time in Korea. So he's a little bit hungover from last night. We had a little too much fun. So go easy on him. But he's going to be just explaining at a high level what he's working on and some of the problems he can be solving here. Thank you. Dominic?
Hey. Thank you, Alex, and thank you for organizing this conference and inviting me, and thank you for reminding everyone that I'm a bit hungover. To make it more difficult for myself, I'm going to just sort of a cappella talk on why I think decentralization is valuable, and specifically try and give some pointers to how you can generate value from this kind of technology. So before I start with that, briefly introduce DFINITY in case you haven't heard of it. DFINITY is developing what we call the internet computer. So that's like a blockchain supercomputer that our ambition is to host the next generation of the world's software and data. On this slide here, you can see a kind of photograph taken in the Palo Alto Research Lab a few weeks back. It's a DFINITY test network. It's a kind of interesting thing. Things like test networks, about 400 nodes. But what we're able to do is combine computers distributed around the internet to create a single supercomputer the world can share. And that has provides all of the properties you'd expect from a blockchain to the software that runs on it. Software can be written in a thing called WebAssembly, or it's a WebAssembly virtual machine, so you can write the software in a variety of languages. And it has some special properties. It's very fast. Will produce finality in a couple of seconds, even though it uses a probabilistic protocol, so it's very resistant to attack. And of course, as you probably guessed from the name DFINITY, it's designed to scale out its capacity as necessary, because there's a lot of software and data in the world. Anyway, I've been in this industry for a long time. Actually, the DFINITY project came out of another project that I worked on through 2014, trying to speed up blockchain protocols by repurposing traditional consensus protocols. And beginning of 2015, I had to abandon all that work. I found a different way of doing things. And so DFINITY's been cooking since early 2015. So, in that time, I've had a lot of, I've met a lot of people and thought a lot about network protocols and also applications that can run on top of these protocols. And actually, in Silicon Valley, there's a really big focus on a thing called product market fit. And product market fit refers to the ability of a product or service, or indeed a decentralized platform, to meet the needs of users and deliver value in some way that persuades people to use your service or product. So I want to go on a sort of a lightning tour of decentralized value, starting with the protocol itself. What's valuable in a decentralized protocol? So for us, when we designed the DFINITY network, we are very keen that the nodes in the network are all equal. And that, even if we have, as our ambition stands, 50 to 100 million computers in the network, each of those millions of computers in the network plays a completely equal role. So there are no single points of failure, and The reason for that is it makes the platform more robust. So the objective of the internet computer is to host the next generation of the world's software and data. And today, the whole world runs on software. So imagine if we succeeded and the whole world did start building on DFINITY, and then the DFINITY network, the internet computer, stopped working. It'd be a catastrophe, right? So we have to design a protocol that doesn't depend upon a small number of special computers, right? And this is one of the ways that we deliver value. We create a symmetric network that is extremely robust. I think the reason this is pertinent to think about today is that a lot of networks have a different design. They've forgotten what decentralization means. Decentralization was invented by the designers of the internet to create a communications network that would continue to function in the event of a nuclear war. Even if there was a nuclear war, they wanted people to be able to continue communicating. So the internet was designed with packet switching, such that, and no central points of control, such that data could be routed across any functional path in the network. And the internet was a huge success. And we'll come back to some other properties of the internet and decentralization that made that possible. But certainly when you're designing a network protocol and when you're looking for a network protocol to build on, you should be looking for real decentralization. This industry is about creating systems that are unstoppable, partly, and extremely robust. So it shouldn't be the case if someone's proposing a decentralized compute platform that it actually depends on a small number of computers. And there are quite a few big projects out there today that depend upon a very small number of special computers. And you have to ask yourself, would the world want to build on top of those networks? When, if a small number of computers fail, every system on top of that network fails too. Doesn't sound very likely to me. Anyway, that's kind of protocol stuff. There was another reason the internet succeeded. So back in the 1990s, there was the internet, which was an open protocol, an open network, and there were also private networks. So in America, you had America Online, you had CompuServe. Back in the 1990s, I was in the UK, and British Telecom wanted to create this thing called the information superhighway. And they said to the government, hey, the internet's going to be very dangerous. It's permissionless. Anybody can create a service on the internet, right? This is really bad. Anybody can create a service on the internet. We suggest that British Telecom creates the information superhighway, and we'll kind of connect everybody to a walled garden, and we'll carefully curate all the content, right? Now, these private networks didn't succeed. Overwhelmingly, the world chose to build on the internet. And there are a number of things about an open protocol, right? So, first of all, because the internet is based on TCP/IP, an open protocol, people could independently extend it. So if you went back to the 1990s, there were, in the UK, hundreds of internet service providers, all of whom were independently connecting to the internet to extend it. That was one reason it succeeded. It could scale out very fast. But the other reason was that nobody needed permission to connect to the internet, right? Now imagine the difference. Imagine in 1996 or 97, you're an entrepreneur, and you wanted to create an online service. What are you going to do? Are you going to go to America Online? I mean, some people did. Do a deal with them so that your special service is available to America Online's users? Or are you going to connect to the internet? Now, originally, of course, probably America Online had more users, but the thing is this. if you built on America Online or CompuServe or the information superhighway had it come into being, your existence would depend on the goodwill of the private network operator. So, you might start off, create some service on America Online, and over time, America Online might decide that they want to create their own version of your service, right? What's going to happen? America Online controls the network, but they've decided that they want to run the same service. Is it going to be a level playing field? Have you got just as much right to provide a service on America Online as America Online has? Of course you haven't. You haven't. It's not an open environment. It's a private, closed environment. So the beauty of the internet was, because it was a truly open protocol, firstly, it could be built out very quickly. And in the UK, where I came from, there were hundreds of ISPs that extended the internet so that everybody could connect. But also, it was possible for innovation to flourish. Like, entrepreneurs flocked to the internet because they didn't need permission. And they could provide a service over the internet that nobody could turn off. And that was a completely different proposition to connecting a service to a private network like America Online or CompuServe or British Telecom's thing. That's why the internet took off and that we had the dot-com boom. And there was this explosion in innovation. So the openness of platforms is absolutely critical. And that's another thing that you need to think about. If you look at a decentralized network and you're thinking of building on top of it, well, of course, you should look at the decentralization, because if the protocol is more decentralized, it's more robust, it's more likely to be reliable and support your service better. But you also need to look at how that network's run. Is it really a consortium? Is it really controlled by business interests? Because if it's really controlled with business interests, and you build your service on this network, and then somebody else builds a competitive service, and the owners, the consortium, the people behind that network invest in your competitor, what's going to happen to you? Right? Mysterious things might happen. All kinds of things can happen. And that, I think, will emerge. But you need to look at the openness of networks. OK, so let's think about building dApps. Let's assume that we found a genuinely decentralized network that's high performance and scalable, and it's open, and there's no chance, it's a level playing field, right? How can we build dApps that are valuable? So these are the last two things in my time here on stage that I'm going to run past you. So the first thing is a thing called platform risk, and this actually is applies kind of like as an adjunct to what I was just describing. In Silicon Valley, the model has been to create, for a long time, to create monopolies. So what happens is you have a new field of business like P2P ride sharing, and initially there's a whole bunch of different competitors. And for example, in P2P ride sharing, you had like Uber, Lyft, Sidecar. There were a whole lot of other ones I can't remember now, and they're sort of forgotten. And originally all of these different ride sharing companies got funding, and then over time, as winners, leaders emerge. Capital is then sort of poured into the leader with the aim of creating a monopoly. Because once you've created a monopoly, you can absolutely mint money. And that's happened in every sector, Facebook, Google, Uber, you name it. So the Silicon Valley model really has been to date to create monopolies. And I'll give you some examples of why that creates a very hostile environment for entrepreneurs. And this is the thing that we can fix on platforms like the Internet Computer and other decentralized platforms. great example of platform risk was provided by Zynga. Who's heard of Zynga, the games company? Zynga was a company in San Francisco that invented a game called Farmville. I forget how many users Farmville had. It was a social game, so it ran on top of Facebook. And I think it got 100 million users or something crazy, and it grew very fast. And Zynga was seen as an extremely successful company. Unfortunately, they were doing very well. They ran an ICO. They had a multi-billion-dollar cap. Everything was going swimmingly. And then, one day, Mark Zuckerberg decided to change the rules on Facebook that governed how social games could promote themselves, right? So poor old Mark Pincus, this guy at Zynga, woke up and he just suddenly discovered that the rules on Facebook had changed. And this fundamentally undermined the ability of Zynga to promote their games. And, things weren't nearly so rosy for them after Facebook changed the rules. I knew a company in Palo Alto that was a unicorn. And the one sort of difficulty they had was that they relied upon the profile data from LinkedIn. So their product needed the profile data from LinkedIn. They didn't see the threat, but unfortunately in 2015, LinkedIn decided that the only people that could access that profile data, well, the only companies were going to be Microsoft and Salesforce. So anyways, this company ended up having to sell itself to Salesforce after losing 75% of its value. This is what's known as platform risk. Now, the reason I'm describing that is one of the greatest ways that these platforms can add value is by enabling us to reinvent internet services in the form of open source businesses using autonomous software. So what that means is, you can reinvent, a business network like LinkedIn using software that has an inbuilt governance system that is used to update it. So, as you probably are aware from, Ethereum smart contracts, these platforms support something called autonomous software. Autonomous software exists independently of a company or a person. That's its power. So you can create an internet service using autonomous software, and you can tokenize it. And this software needs to have an inbuilt governance system that is ultimately controlled by the token holders. And this can, adopt software updates, which can be collected from the community, right? So what we're doing is, we've already got open source software, but we're creating a business, an internet service that's also open source. Now the actual operation itself, the service itself is open source, right? And in the design of the autonomous software that creates the open LinkedIn, that has no company or person behind it, you can provide guarantees about how people will be granted access to the profile data. And the reason this is important is it provides you a way of de-risking the proposition for other entrepreneurs that want to build on top of your system, right? And this is why eventually, I don't know how long it's going to take, but things like dApps on the internet computer, internet services running on the internet computer will explode because people can re-engineer internet services in open source form. And these open source versions of internet services can provide people, other entrepreneurs and other systems, with much, much better guarantees about, for example, the availability of APIs. For example, the LinkedIn profile data, right? So now think about this. Imagine you're a young entrepreneur and you see the traditional centralized, monopolistic internet. right? And then you look at these decentralized computation platforms where the internet services are open source businesses, right? And you can build against their APIs with guarantees that they won't be taken away. Which would you choose to build on? You'd choose to build on the open platform because there's no chance you're getting rid of your platform risk. There's no chance that your use of those APIs, your access to those APIs is going to be taken away from you. So what this will lead to is a kind of mutualized network effect, right? Currently, on today's monopolistic internet, the aim is to create an internet service that reaches sufficient scale that it can establish network effects and become a monopoly that nobody can compete with because they've established a monopolistic position, right? But the network effects are limited to the monopoly, to the single monopoly. And the great opportunity here is to create a new internet, which is decentralized, using autonomous software to build open source internet services that provide each other with guarantees about how you can access their data and APIs. And therefore, this open internet, this open decentralized internet, the participants will benefit from mutualized network effects, right? If you have the open LinkedIn and it is succeeding because it's established network effects and everybody wants to be on it, well, guess what? Now those other interesting services that extend the decentralized LinkedIn, they can benefit from its network effects because they can access APIs without risk they'll be taken away. And likewise, the LinkedIn service can benefit from all these other services innovators and entrepreneurs are adding on top. So anyway, yeah, that's it. It's a big topic. There's lots of ways that you can add value in this space. But I think considering openness and the value of openness is absolutely essential to the planning for any decentralized service. And that runs right the way from selecting the network that you want to build on top of through to designing your own architecture and thinking about how you can provide guarantees for other entrepreneurs who might want to build on your service. Anyway, okay, that's it. Thanks.